Welcome back to The Explainer. Today we're talking about something where failure is literally not an option, building the ultimate response vehicle. Look, when you're tasked with sourcing a fire truck, you aren't just buying water and wheels, right? You're investing in life-saving reliability. The stakes are absolutely massive. Getting this right means really understanding what goes into these incredible machines. Let's get right into it.
Okay, let's dive into this. What actually goes into building a reliable, life-saving fire truck? I mean, for a lot of municipalities and industrial facilities, local procurement costs have completely skyrocketed lately, and that creates a terrifying risk, under-equipping a department just because of budget constraints. But what if you could get customized, world-class equipment without totally breaking the bank? Well, that's exactly why so many global fleets are actively looking to China for their procurement needs.
So here's our game plan for today. We're going to cover the global manufacturing advantage, the anatomy of a fire truck, matching apparatus to application, breaking down the costs, and wrap it up with the B2B procurement workflow. Consider this your strategic roadmap to getting all those fundamental procurement questions answered systematically.
All right, part one, the global manufacturing advantage.
So if you're a procurement officer, this is phase one of your buyer's journey. Why are fire chiefs around the world suddenly looking east? Well, the main advantage of working directly with Chinese OEMs, original equipment manufacturers, is that it completely solves the headache of rigid local specs. Instead of settling for a generic off-the-lot model, you get incredible flexibility. You dictate the exact payload capacity, tank materials, and equipment layouts for your specific operational conditions. Combine that with highly competitive manufacturing costs and access to world-renowned commercial chassis platforms, and yeah, the appeal is pretty obvious.
Moving right along to part two, anatomy of a fire truck.
Let's put on our hard hats for a second and break this build down right from the ground up. The chassis is the absolute foundation here. It dictates your payload, your stability, your maneuverability, all of it. Manufacturers over there offer several distinct platforms. Take the Isuzu chassis, for example. It's famously fuel-efficient and agile, making it the absolute go-to for tight urban routes and municipal departments. But say you're dealing with a petrochemical plant, you need something that can handle a tremendous payload. That's where a heavy-duty option like Sino Truck comes in. It's built specifically to carry massive industrial loads without compromising stability one bit.
And this brilliantly illustrates one of the unsung mechanical heroes of the whole setup, the power takeoff, or PTO unit. This isn't just some fancy add-on, it's a critical mechanical link. The PTO transfers the engine's power directly to the water pump. When a crew is in the middle of a prolonged, intense emergency, the literal last thing they want is a drop in water pressure. The PTO is what guarantees that consistent, life-saving water flow, hour after grueling hour.
Now let's talk about what actually holds all that water, the superstructure materials. So carbon steel is highly cost-effective up front, sure, but it requires rigorous anti-corrosion treatments, and it's definitely prone to rust over time. Polypropylene, or PP, on the other hand, an absolute game changer. It's incredibly lightweight and highly corrosion resistant. If your fleet operates in a humid, coastal environment, opting for a PP tank ensures your truck stays out in the field fighting fires, instead of sitting in a repair shop bleeding your budget over severe rust issues.
Okay, part three, matching apparatus to application.
How you build the truck completely depends on what you're actually fighting. Think about it. A standard municipal fleet faces entirely different challenges than an industrial response unit. City environments demand versatile vehicles with super tight turning radii to navigate narrow streets, and they usually rely on centrifugal pumps for standard structural fires. But if you're protecting a petrochemical plant against Class B flammable liquids, a standard water pump simply won't cut it. You need heavy-duty foam systems and high-velocity remote deck monitors to knock down those massive chemical blazes from a very safe distance.
Now, what's really interesting about this slide is how mapping these requirements out instantly segments your facility's needs into the exact right vehicle profile. A water tanker handles urban fires efficiently with up to 10,000 liters, but look at the foam tender down there, designed specifically for petrochemical hazards, scaling all the way up to 16,000 liters of foam and water mix. Meanwhile, rescue vehicles skip the water entirely to transport heavy hydraulic tools for structural collapses, and aerial platforms specialize in high-rises with reaches up to 60 meters.
I want to pause on that 16,000-liter number for just a second. To put that into perspective, that is roughly the volume of over 100 standard bathtubs loaded onto a single mobile chassis. It's wild.
But that staggering capacity visually emphasizes exactly what industrial readiness truly means. When an oil terminal catches fire, you need extreme heavy-duty suppression to actually knock it down. Accurately analyzing your hazard volume is what prevents the costly and potentially fatal error of under-equipping your department.
Moving right into Part 4, breaking down the costs.
Let's pull back the curtain on actual, realistic procurement pricing. For the procurement teams watching, you might want to grab a pen. This data provides a highly realistic baseline for structuring those high-stakes departmental budgets. You can see how surprisingly accessible these entry points are. A small water tank fire truck starts right around $35,000, while a heavy-duty foam fire truck ranges from $1 to $200,000. Even the highly complex aerial platforms with massive booms top out around $500,000. But remember, these are just baseline estimates.
So the crucial point here is understanding what pushes your final price up or down within those ranges. Your chassis brand is a massive factor. Imported chassis will naturally increase the cost, whereas domestic Chinese platforms give you a much more economical solution. Scaling up tank capacity also increases costs because, well, you need a stronger subframe to hold all that weight. But here's a fantastic insider strategy a lot of fleets use: integrating premium imported international pump brands like Hale, Darley, or Waterous onto highly economical domestic chassis. It gives you world-class pumping reliability while keeping the final quote incredibly competitive.
Finally, Part 5, the B2B procurement workflow. All right, we have our specs and we have our budget. Now we need a concrete action plan to execute this international purchase safely and efficiently. Before any contracts are signed, you absolutely must verify compliance. Leading Chinese OEMs can for sure engineer vehicles that adhere to strict global standards, like the European EN 1846 or the American NFPA 1901 upon request. But you have to ensure you're working with a capable factory. It is critically important to verify a manufacturer's export experience. Literally never sign an order without explicitly requesting specific, documented test reports for critical metrics like braking distances and pump flow rates.
Let's move to the workflow and see how this builds. What seems like a daunting international transaction actually breaks down into 4 highly manageable steps. First, confirm your technical requirements, everything from required pump flow to local emission standards. Second, review the manufacturer's configuration proposal and technical drawings. Third is production and quality inspection, where the OEM rigorously tests for water leakage, driving performance, and electrical integrity. And finally, shipping and after-sales support, ensuring you actually have the operation manuals and spare parts list you need to keep that truck in service for years.
Keep in mind, this entire process operates on a standard lead time of 45 to 90 days. Custom manufacturing takes time, you know. You're building a complex, life-saving machine from the ground up, so you really need to finalize your detailed technical drawings well in advance. Do not wait for an aging fleet to fail before you begin this evaluation process. You have to procure your replacements well before an emergency strikes.
Which leaves us with the ultimate question. Is your fleet actually equipped for the worst-case scenario? For the facility managers, procurement officers, and fire chiefs out there, I urge you to actively review your fleet's readiness right now. Take the actionable insights from today's explainer, thoroughly analyze your local hazards, evaluate your chassis and pump options, and ensure that when the alarm sounds, your crew has the precise machinery they absolutely need to save lives. Thank you so much for joining me to explore this vital topic, and I'll catch you on the next explainer.